Hey everybody. So we've been assuming ideal op amps where the current going in here and here, they are 0, and the voltage here on the non-inverting input is equal to the voltage here on the inverting input. But what if we don't? So this is a more realistic representation of an op amp where there is input resistance here that's less than infinity, an output resistance here which is more than 0, and there's actual gain here that's not infinity. So, and then these are realistic numbers, so the input resistance here typically is 2 mega ohms, the gain here is typically 100,000 or so, and the output resistance here is around 75 ohms. Okay, so let's focus on the method we're using to analyze a circuit that looks like this, more so than the answers. Okay, so this is an application of the inverting amplifier, but now utilizing the more realistic representation of the op amp. So what should we do? Okay, let's use KCL at node A, so node voltage method. So at node A, KCL, the voltage there is Vn. So let's find the current here. So Vn minus Vs over Rs. And now the current going this way. So Vn minus Vo over Rf. And now the current this way. So that's Vn minus over here is 0, right? Because there's Vn and there's ground. So 0 over Ri. Okay, now there's also an essential node here. So the voltage here well, technically this is not an essential node. So let's just use Ohm's law or KCL here. So KCL at node B, there's current going this way, Vo minus the voltage here, A times Vp minus Vn over Ro, and then the current here, Vo minus Vn over Rf. Okay, so the goal is to write the output as a function of the input. But then we have another unknown here, Vn. Right, so we just need to solve one equation for Vn and substitute into the other, and then we're left with two unknowns, which is just, there's Vn over here, and then we're left with two unknowns, this and this. The output and the input, and I notice already there's Vp right here, which is tied directly to the ground. So that is 0. Right? This is tied straight to the ground. So this is 0. I'll just write 0. Okay. So if I work through really quickly, let's say you take this one, solve for Vn. So let me just write this, Vo. So this is minus A times minus Vn, so plus A Vn. Okay, so just take these two, move it on the other side of the equation. Okay, so Vo times 1 over Ro plus 1 over Rf equals, and then on the other side of the equation, 1 over Rf minus A over Ro. Okay, and then put this in the denominator here. And then this is Vn. Then take this and put it here. Right here. Okay, and then we're left with one equation with VO and VS, and then just move everything. Right, move everything VO on one side of the equation, move everything VS on the other side of the equation. Okay, let's try one more application. So this is the non-inverting amplifier. So let's look at this node right here, node A. So let's do KCL at node A. So if we find the current this way, Vn minus 0 over Rs. Okay, now let's find the current this way, Vn minus Vo over Rf. Now let's find the current this way. So notice that these two resistors are in series. So Vn minus Vg over the two of these in series, Ri plus Rg. Okay, now let's take a look at right here, KCL at node B. So let's find the current this way. That's VO over RL. And then the current this way, VO minus, okay, it's 0 over here, and over here is A times VP minus Vn. A times VP minus Vn over RO, and then the current here, VO minus Vn over Rf. Okay, and then we want the output as a function of the input. Output and output. Okay. But then we also have Vn and Vp. We have too many unknowns. So notice that. Let's just focus on right here. I'll just draw it again. So here's this right here, Ri and Rg, those two resistors. The voltage up here at the top is Vn over here. The voltage right here is Vp, write it on the side, Vp. And then over here is 0, and over here is Vg because of this voltage source. Okay, so notice that the current this way, right, is the same as this way. I mean, these are in series, so it's the same current. So if we just take a look right here, Vp minus Vn over Ri, right, that's the same current as if we just, this whole thing, Vg minus Vn over these two in series, Ri plus Rg. Right? This is the current here. This is the current here. Now let's move this on that side of the equation. And we can substitute this right here. So then it'll be a function of Vn and Vg. So maybe I'll just write that right here. And then Ri over Ri plus Rg. Okay, now what's unknown? There's Vn and this was our input. Okay, so all we need to do is, for example, solve this for Vn and then plug it in here. Then you'll have one big mess with VO and VG. And then you just simplify, so then VO will be a function of the input VG. A huge mess, but I'm more concerned with using the method than the big mess of an answer. Okay, so give these a try. Just practice the method, and then you don't have to spend so much time simplifying all the mess of an algebra. Just practice doing the method. Okay? So hope that was helpful. I'll see you on the next video.